All right, welcome to your last week. I am going to ask one favor of you, and would you all please do it? Please fill out course evaluations. For the 9 week, I didn't even have 10%. Even my boss said, wow, you usually get a lot of people to do course evaluations. You can say, well, I did. Okay, well, thank you for doing it. If you do it again, if you have problems with the way that class is being taught, or if you have problems with me, or you have problems with a book, or anything else, please put that down. All right, they will all go to my boss. All right, if you do give me a lot of unfavorables, then please explain why. Okay, it's okay if that's the way you feel. That's your right, but explain why. I've had people do that before where they put down, for most of the time people write that in, even though I told you not to, and they give me zeros or whatever for everything, and then on the back they write down, course was great as it is, don't change anything. It's like, so the front said it was terrible, and the back says don't change a thing. So either you like terrible or you didn't understand the grade system. All right? So now I will tell you, just so you know this, as always, there's a folder out there with today's date on it. That folder has in it what we're going to be doing this week. First, I'm going to show you this non-GUI Java calculator. That's the one I gave you the hard copy of. All right? Then I'm going to go right back into that file. All right? I'm going to go right back into that file, and I'm going to put some error handling in it, or show you error handling. Then finally, it's going to be rebuilt. So if you see this, and I just want to show it to you, so you can see what we're building toward by Wednesday, and we'll probably at least start on it today. And here's the GUI, just so you see it. You go, well, we never made a GUI before. Yeah, it's not hard. In fact, you might say afterwards, why didn't we just do GUIs from the start? Fair question. I can't give you an answer. Maybe because the book didn't talk about GUIs before then. Now, notice you might or may not notice down here it says source and design way down at the bottom. Notice if I click design, you might not like my choice of colors, but that's what we'll be building. It's not difficult. In many ways, it's similar to what you do in Visual Studio. It's not identical. You may or may not like it as much, but I put that in there. And I kind of pulled out the error handling because I didn't want this to get too big. But I'm going to show you how all of these were done. All right, so for now, I'm just going to close this because, again, that's what we'll be building towards. So I don't want to go through that right now. So let me close the project. And the first thing I'm going to do is open up this thing that's called Calculator Non-GUI. And again, you've got a copy. And I don't know, I just heard one of you back there saying how tired you were. It seems that, especially when the last week kicks in, that people are like, God, I just want to get the hell out of here, type of an idea. Guess what? Instructors feel that way too. The only people who don't feel like that are lab assistants. Isn't that right? No. Okay. But I want to show you what's in this, and then I want to run it, and I purposely want to introduce some mistakes in it, very similar to the mistakes that you maybe have come through, had yourself, or maybe, for example, when you, even when you were doing the payroll program, if you accidentally left the hours worked or the hourly rate blank, or you accidentally put in a non-numeric character, how the program blew up. All right? So this one has nothing in it to keep it from blowing up. In fact, I'm going to make it blow up, when we start running it in just a bit. All right? Then I'm going to show you actually 2 or 3 different things that I put in to make it better. All right? And I'm going to introduce you to the Java try-catch statement. Now, there's a lot, believe it or not, there are a lot of people who hate try-catch. And if you go out and you do a lot of reading on it, there are people who will tell you you should never, ever use try-catch because it really can slow down performance. And there kind of is a way to get around try-catch. The way that you get around it, it's probably something Denny either showed you or talked about with you. Did you go over in the C# class, not to try-catch, but to try-parse? Did you go over that? There's something similar to that you can do in here. So you can read everything in as though it's a string, and then you can check to see whether or not you can convert it to a number. All right, so we'll talk about that too. So I want to spend a little time on this and make sure you understand it. I kept this simple. And when I say simple, This is a real simple calculator that does 4 things. You can add, you can subtract, you can multiply, and you can divide. I said, forget about modulo. You all know what modulo is. I didn't really care. All right? So just to show you what's in here, again, even the comments are very small. Create a non-GUI based calculator using Java. That's it for the, and I left it in there basically. All right. I put a decimal format in here just because of the fact that, and you've seen this before, that if I divide 37 by 4, for example, I didn't want to get 9.66634 or something like that. I just wanted it to be 2 decimal places. So that's why that's in there. All right, the J option pane's in there because I tried to make it a little bit GUIized, even though it's a non-GUI app. Again, I could have done this using the system.out.println and using the scanner class, which some of you have done for most of the semester. All right, but I decided not to do it that way. Again, be it right or wrong. All right, so I call this, as you can see, calculator non-GUI. Okay, you notice there's 2 constants in here. So the smallest number you can put in is a 1. It's 1 for add, 2 for subtract, 3 for multiply, 4 for divide, and 5 to end the program. Does that make sense? And when you look at this, my hope is that at least in your head, when I run this, and I believe it or not, I was going to change it, but I purposely didn't. If you start thinking to yourself, why did he do this? Why didn't he do it here and do it? Then you're starting to think like a programmer. All right, anytime you take a look at any code, be it online or that I write or that someone else writes, and if you say, wow, I could have done a better job with it, that's a good thing. All right. I don't know, did you ever see the old, what was it, Rocky 3 or Rocky 4, when at the end, Rocky's fighting Apollo Creed, and it's just the 2 of them in there. All right, and he said, you taught me too good. And there's like an old saying with that is, yeah, you taught me everything you know. And then the person turns around and goes, no, I taught you everything you know, not everything I know. You understand what I'm saying? I don't believe in that philosophy. If you leave here and you're a better Java programmer than I am, I've done my job. I don't have any problem with that at all. Do I have an ego? Of course I do. When it comes to this stuff, not at all. Because I'm not going to be going for the same Java programming job that you are. So if you're better than me, then hopefully that bodes well for the school. All right? I don't care that much about my own reputation. People around here know who I am, and they like me or they don't like me. But I'm more concerned with you. So there are a few things in here that when you see them, you might look at it and go, why'd you do this? Why'd you do that? All right? That's good. All right. So this will be the actual selection that you'll make that should be between 1 and 5. Then I had to put the symbol in here. So as it says, it'll either be a plus or a minus or a multiply or a divide symbol. That should all make sense. We've got 2 different numbers in here, num1 and num2. And then I'm going to either add those 2 numbers, subtract one from the other, multiply, or divide. So result is going to be the result of the calculation. And then again, I figured that it wouldn't get anything bigger than that, but I wanted to make sure that I put in a decimal formatter so it was just set to 2 decimal places. Any questions on that? Because when we get to the next iteration, I'm not going over this. All right? Okay. So I put a Boolean in here called keep going. I can't use the word I'd always wanted to use in here to keep going, which is continue. Why can't I use continue? Because it's a key word. All right? So keep going seems to work. You all should know by now that this is a shortcut for while keep going equal true. All right? Why you would ever want to type that when you can type this, I don't know. But as I've told you before, if it makes more sense to you to do this, you can. I will tell you that if you get a job as a professional programmer and you type like that, you'll get a reputation and it won't necessarily be a favorable one. All right? So I'm trying to basically say as long as I want to keep going here, okay, then I'm going to call this input number and I'm going to call it for num1 and I'm going to call it for num2. We're going to look at that in just a second. In fact, let's look at it right now. It's very short. Okay, so I say numString equals this, and then I'm just returning double.parse double. All right, one of the nice things about doing it the way I've done it here is that I only needed 1 variable. And I probably could have even figured out a way to do this where I could have returned this and put this all in one function. Watch out when you do stuff like that, because sometimes people try so much to take their code and cut it down and cut it down that it becomes very hard for others to read and understand. I didn't think, though, that this routine here with about 8 lines in it was hard for anybody to understand. All right? But again, as you can see, please input a whole number. In fact, it doesn't even have to be a whole number because I had it at double. So really, instead of a whole number, I should have just said, please input a number. That would have been better. All right? So I'll just keep mine like that. It doesn't matter if you change yours or not. But the point is, where it says please input a number, if I put hello or if I leave it blank, the program is going to blow up. Does that make sense to everyone? Because that's one of the things we're going to fix in the next iteration of this. All right? Okay, so we do that twice, for the first number, for the second number. Ideally, by that time, we've got a valid number. So let's say, for example, and I'm just making this up, I put in 55 for the first number, and I put in 7 for the second number. That does have no meaning, all right? But now I should be able to either add them, subtract 7 from 55, multiply them, or divide 55 by 7. That should make sense to everybody, okay? So I call next, show menu make selection. It's a little longer. All right, show menu make selection. Well, this is what's going to come up on the screen. Enter a 1 for the sum, a 2 for the difference, a 3 for the product, a 4 for the quotient, and a 5 to end the program. This is one place this program could have been improved, because even if you want to end the program, you still have to enter 2 numbers. So it would have been possible to fix this, to ask the user, do you want to just stop right now? All right, I didn't do that. All right, if you want to fix that, you could fix it. So we ask you to do this. Then we do a parse int on that. Again, what should have been entered is a 1, 2, 3, 4, or 5. All right? If you've entered a number that's less than 1 or that's greater than 5, just ask you to do it again. Does all that make sense? So the idea is, once we get to this point, notice there is no return. So once we get down to this point right here, selection will have a valid number in there. 1, 2, 3, 4, or 5. All right? That's the whole idea behind this routine right there. All right? Then result is call correct method, and I'm passing selection. And I looked at it later and I thought, you know what? I didn't even have to pass it because it's up there. But I did. It doesn't hurt anything, so I'm just going to leave it the way it is. So here's the selection. All right? And again, could this have been cut down? I could probably cut the number of lines I used in half if I really tried. All right? But what I'm doing in here is, notice, all I'm doing in here is calling the correct method. I'm setting the symbol, but then I'm calling sum. Setting the symbol, calling difference. Setting the symbol, calling product. Setting the symbol, calling quotient. And if you put in a 5, that's just system.exit 0. All right? So what are we doing in here? Sum, return num1 plus num2. Difference, return num1 minus num2. Product, return num1 times num2. Well, I did check in here. And I said, basically, if you try to divide by 0, all right, just say illegal attempt to divide by 0 and return 0 right there. So don't even do the division. That's as close as I came in this program to putting in anything as far as error checking. All right, so if I take what we have here and I run it, okay, it said 55 and 7. It's always good to use numbers that, you know, I've watched people test this. I'll say this and you might laugh or think that would never happen. No, I watched a person testing one day. All right, they were having problems, so I just was sitting next to them, and they were putting in numbers like pi. And I'm like, are you almost done? No, I'm just starting to test them. Why do you put in numbers where it's hard to figure out what the sum or the difference or the product or the quotient would be? I don't understand that. So, all right, so we do a 2. 55 minus 7 equals 48. Looks good. 55, 7. If we add them, 62. 55, 7. Product looks good. 55, 7. Notice it's 2 decimal places. Again, could this have been fixed? Could we have used the same numbers without having to put that part in a loop? Sure, we could have. It would have been a little bit more work, but you could have done that. All right, I just left it the way it was. And the other thing is, again, notice if I put in here 55 and 0, and I say that I want to divide, it comes back and says, illegal attempt to divide by 0. All right, and then it gives you that. That may or may not be actually a true number, because 0 times 0 is not 55. You all know that, but I did put the message in there first. All right, so here's where we run into problems. Please input a number. No. Well, notice what I got here, a number format exception. All right, what does that mean? Literally what that means is it's telling you, this is what the system sent back. You passed in an empty string. An empty string fails the test for an int that we're looking for. All right, so you already saw this part that if I run it again, all right, I'll put in again 55 and 7, but if I put in a number that's too small, it just tells me to do it again, or too large, it tells me to do it again. Oops, I don't know what I did there. Let's try that one more time. Okay, another number format exception. Why? Because evidently I didn't put my check in there correctly. All right, but you'll see this throughout the program. In other words, you saw part of it, but if I come through here and say 55 and then leave this blank, again, a lot of number format exceptions in here. All right, so the first thing I attempted to do was to come back in and try to fix those. So what I'm going to do here is I'm going to close this one. And I'm going to open up version 2. It looks exactly the same. And what I mean is, when I run it, it's going to basically run the same way. But notice what I've done in here. This is my file. Okay? And I really don't need this, but it was suggested that I put it by the system, so I allowed that to go in there. This is the first time, and this is something you'll see next semester. I think it's chapter 11 is on exceptions. But in this case, I wrote my own exception. And what happens is if I attempt to divide by 0, what's going to happen is, and I'm going to show you all this stuff I've put out there. But this says if number 2, all right, equals 0, then even though I did this, it doesn't matter. I'm throwing a new exception that says illegal attempt to divide by 0. That's my exception. So for instance, remember back when we were at the beginning of the semester where we did the miles per gallon? Let's say that you had a minimum number of miles and a maximum number of miles, or a minimum number of gallons or a maximum number of gallons. You could literally have written 1, 2, 3, or 4 different exceptions of your own that would handle that. When you write an exception, all right, you have to extend either the exception class or a class that's part of the exception class, and that's arithmetic exception. All right, and notice I passed in here that message, that thing, illegal attempt to divide by 0. And then basically you have to call this, all right, and again, that's calling the parents. So that's calling the constructor of basically of exception, really of an arithmetic exception, which calls the one of exception. But it'll print out that answer for us. So you'll see that when I run this, and now when I come in and I say 55 and 0, all right, and I say that I want to divide, yeah, the program blows up, all right? But it blows up with my error, illegal attempt to divide by 0. Notice, divide by 0 exception. That is my exception that I wrote. You saw it before where it was a number format exception. So you might say, well, why did you do arithmetic exception? I could have done number format exception too. All right. And you have your choice when you do this, but there's a couple things I very quickly want to show you about this. And that is, first of all, I used to do this and almost have people repeat it after me just so you use it. right there, okay, that is me throwing an exception. Now, why am I telling you that? Because if you remember in the past where we did IO exception, remember that when we were doing it, we put what? We didn't say throw IO exception, we put throws IO exception. So if there's an S on the end of the word throw, that means that Java itself is explicitly, I should say implicitly, I guess, they are the ones that are throwing the exception. But if you say throw, that means you, the programmer, are implicitly throwing your own exception. Does that make sense? Because that's a big hallmark of what that chapter is about. All right? So I want to show you the rest of the stuff that I put in here. Okay? All right. So here I've got if the number is 0, that's what we had to begin with. That was from the last iteration of it. All right. Well, I could have done this too. And what's the difference between this one and this one? You might say, well, one says a legal argument exception and the other one says divide by 0. And that's true. But the main difference between these is this is a built-in Java exception and this is my own exception. So what I wanted to show you there is there's two different ways that you can do that. All right, again, you can either throw your own exception or you can throw one of Java's built-in exceptions. All right? All right, so I have to say that the program still throws this, and I had to say it, I think, up above someplace too, there. All right? And again, that may or may not make sense to you, but I want you to at least be exposed to it. The other thing I did in here was this. This is how, for lack of better words, this is how Java does exception handling, natural exception handling. What you do is you put inside of your routine here what's called a try catch. All right? And after the try, inside of the curly braces, you put in any code that could possibly fail. All right? And then after the catch, and I only have one, you can have as many catch statements as you want to or need to have. But the point is, when you, let's say I had multiple ones here. So let's say I wanted to also catch what's just called an exception. And I'm not going to do anything right now, but just so you see that. The real key thing here, and I want you to understand this, is this. And that is, this is a more generic exception, and this is a more specific exception. Does that make sense? Exception just means something went wrong. You hardly ever throw a regular exception in Java because the compiler is much pickier than you would ever be. And it'll flag things as exceptions that you probably don't think are exceptions. All right? But the point is you have to have the more specific ones before you have the more general ones. Okay? All right, so I could put that in. Now, the other thing to realize is, because I've seen people do this, so I want to come in here and say int age equal 21. I mean, it's a dumb example, but I'm just putting that in there. If I create this variable inside of this try block, it only exists in here. If I decide I want to use age in there or in there, I can't. So if I do want to use age for some reason, check it here and use it here and here, then I have to define it outside. And it may not sound like a big thing, but I've watched people do that. I've explained it, then I still see them screw it up. All right? So again, this is better. It's still, is not perfect, but it's better. All right, so again, notice now when I run this, and I leave it blank, non-numeric input, resetting value to 0. Now, is that great? No, but the program's at least still going to run here. So leave that blank, non-numeric setting to 0. All right, if I do say 4 here, I'm still going to get my own error that you already saw. but now I can add or subtract or multiply. It would have also been possible in here that rather than resetting it to 0, I could have set it to anything I wanted to. It's also possible that if I wanted to, in this catch block, I could have another try catch and I could try doing it again. The problem is if the person's kind of beyond repair and they keep leaving it blank or entering something non-numeric, then you end up having a catch with a try in it, that has a catch with a try in it, that has a catch with a try in it, and you can keep doing that. The system will be more than happy to do that. All right? The other thing I want to mention to you about this is if I have this catch, another thing I can put in here if I want to is the word finally. And what happens is the system goes through and it tries to do this. Let's say this works and this works. Then it skips everything that's in here and it does whatever comes after the finally. If I do this, and let's say that it screws up right there, well, then it never gets to this line. It does the catch, then it does the finally. So the finally runs whether the try succeeds and there's no catch, or whether the try fails and the catch, or one of the catches, is executed. Typically, the reason you use finally is if it's a bad enough error and you've got, for example, a database open or a file open, that's where you would close the database or you'd close the file. All right, so usually if you use a finally, and you don't have to. But if you do, you use it for housekeeping operations. Finally, just no pun intended, but just so you know, you have to either have a try catch or it is legal in this language to have just a try and a finally. All right, you don't normally see that in programming, but you can do it if you're so inclined. All right? All right, any questions on any of this? Again, you're going to have a whole chapter on it in Chapter 11. All right. One of the things I'm thinking of doing is I haven't done any work for this, okay, for this class for fall. But I do have, from when I taught it a year ago, and it was an older version of this book, I might just grab all those lectures and pull them out and put them out there on Blackboard. You know, some of you like to get ahead a little bit and take a look at what, so the chapter numbers may not line up, but I'll make sure that the chapter names still do line up. Because like I said, it was another version of this book. All right? Okay. So other than that, like I said, this whole thing runs just the same. So I'm asking, last time, any questions? Go ahead.
For the whole thing, seeing that you have the variables declared outside and they're public to everything, do you take a performance hit versus declaring them and passing them inside the...
The question was, if you take these and you make them public, do you take a performance hit as opposed to just putting them in the routine where they're needed and passing them if you have to? Typically, the performance hit, almost none. But what you get with this is you get what are called side effects.
Yeah.
And side effects are sometimes what you want to have happen. But now I can change the value of any one of those inside of any routine because they were defined at the top. All right. The other thing, too, is can somebody tell me, real simply, don't make it hard, why do I need that word? Why do I need the word static in front of all of those? Like I said, don't make it hard. The idea is it's because main is inside of here. And since main is static, everything that main calls has to be static. And everything that main uses has to be static.
Is that like in C# where you have to do public?
It is, yeah. Yeah, these are access specifiers. All right. But if you pull main out, you don't need the word static in here at all. And none of these have to be static either. But since they're all called directly or indirectly from main, that's why we need static. All right. Did I answer your question? Okay. Any other questions? All right. Then why don't you do this? Just why don't you, if you're not in Eclipse, get in Eclipse, start up a new project, call it calculator, that's fine. And what I'm going to do is I'm going to build it from scratch with you. all right, the one that's called Calculator GUI. And if you do get a little bit confused, I have all of the steps here. There's 14 steps, okay? And I'll probably go back and forth. I want to cut this down because otherwise it's going to print real funky like. But I'm going to cut it down to about 12. That should print okay. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to quickly print out 10 copies of this. So while I'm doing it, all right, if you could, if you're not in Eclipse yet, get in Eclipse, start up a new project, all right? If all I want you to do, please listen to this, all I want you to do is to go in and start up a new project. Don't add a package, don't do any of that other stuff. Well, I already did that. Well, then just close that one because we're going to start up a new one. And if you're confused, don't do anything until all these print. All right, John, would you mind passing them out? I'd appreciate it. Thank you. And I'm doing that. Sometimes some of you either fall behind or some of you like to go ahead of everybody else. Okay? And that's the reason for it. So you literally do have in here all of the code. You may not agree with the names that I used and whatever. And you're like, can I use my own? You're not turning this in. You can do whatever you want to do with it. All right? If we do get this done by the end of the period between now and the break, after the break, and then if we finish it then Wednesday will just be a lab day. So for those of you who have finished everything, if you've finished everything and I've graded it, you already know what your final grade is. All right? If you don't believe me, ask Damien. Right, Damien? Okay. And some of the rest of you have finished also. Okay? And the same thing holds true in the 167 class. All right? By and large, everybody who's in this room right now, I don't have attendance problems with any of you. That's the good news. The bad news is this is half the class. So some of the rest of the people who are in this class, literally, some of them have been MIA, missing in action, if you don't know what that is, but literally, not for weeks, but for months. And it's not always the first year people either. I've got one of my second year students, he does have medical problems, but what does he come, 3 times this year? In fact, the class is surprised when he does walk in. Okay? The difference is last semester, even though he was not here, he was doing the work. Now he's not here and he's not doing the work. Hopefully he doesn't think that on Saturday this week he's going to graduate, because it ain't happening. All right, let's just walk through these as John's getting this stuff ready. So we're going to do a file new project. All right, but notice what we're going to do then. We're not going to come in and we're not going to create a package. Instead, we're going to choose new file, new other, and go down to where it says window builder. The good news is, through luck or skill or John Wanda, through one of them, window builder was put on this system, because actually window builder is an Eclipse add-on. The reason I'm telling you that is if any of you have loaded Eclipse on your own machine, you may or may not have window builder in there, because it does come in as an add-on. All right? But we're going to do that. And as it says, we'll leave the package set to default. We'll set the name of the thing to calculator, and then we're going to start building the actual GUI. All right? Am I an expert in this? I am very far from an expert in this. All right? But ideally, at least, it'll be simple enough that you'll all be able to go through it and understand it. The advantage of doing that, what I'll show you in fall is how to do this in code. Did Denny ever have you do anything where you built a GUI in code?
No.
Yeah.
Oh my God.
How many of you would want to do that? Let's see a big show of hands here. All right. Because that's what they show you in like chapter 12, is they show you how you can create a GUI and how you can create it in code. Just because you can do something doesn't mean you do or do not want to do something. All right? And before you say, Jesus, I never want to do that, What happens if you become a Java programmer and you're put on an app that's a legacy app that's been out there for a while that someone else wrote, and they did set it all up where they set up the GUI by hand? Don't think that doesn't happen. It does. All right. So again, I'm going to bounce back and forth between this one and actually what we're doing. So let me close this one that I'm working on here. All right. So what I want you to do then is to come in here, do a file, new, as we've always done, Java project, and I've got calculator GUI. I'm just going to call this calculator, just like we've been doing. All right, and click finish, just like we've been doing. So you've got this. Right now, there is no package. All right, you literally can put a package in there, but in all of the examples that I've looked at online, they don't put one in. So I'm going to right mouse click on the file here where it says source. John, if there's any extra of those, I would take one, if there are any. All right, and we're going to do a new and other. Here I cut down the size so I could print it portrait, and then I printed it landscape anyway, which just wasted some paper that we probably wouldn't have had to waste otherwise. All right, so after you go and do a new other, make sure you're in the source folder here, right mouse click, new, go all the way down to other. All right, so click other. And what you'll see when you look in here, yours may or may not look like mine, but if you do peruse your way down, there should be a folder here that says Window Builder. Is there anybody who's trying this that doesn't see a folder called Window Builder? All right, if you find Window Builder, click the plus to expand it. All right, and if this isn't open, it might be closed here. Okay, open up Swing Designer, and where it says Application Window, click there. All right, and choose next. Okay, now they're asking for a name that we want to use. Notice what it says for the package. It says the default package, which works just fine. All right, and I'm going to again call this calculator. Okay, it doesn't matter that it's the same name as the other one. It's fine. All right, it even says there the use of a default package is encouraged, so we could have made a package first. All right, I read through over the weekend 4 different things that were on this. Every one of them, they didn't create a package, which is the only reason I'm not. All right, so I'm going to click finish. All right, and you should come up with code. All right. Does everybody see that? Do you see code? Now again, it might look a little different, but it really shouldn't look much different. The big thing is, in the past, we've had almost no code. Now the system is starting to build the interface for us. All right. Also, hopefully what you notice down at the bottom of the screen here is there's a thing that says source, and there's one that says design. Is there anybody who can't see those on your screen? Click the tab that says design, please. And it should look like this. Again, I don't want to lose anybody. So if you try something and it doesn't work, raise your hand. I'll help you, or John will help you, whatever. Now, we don't really need this stuff anymore, and you could close it, but there's a faster way to do it. Where it says calculator.java over here, if you double click, it hides it, and if you double click again, it brings it back. All right, so I'm just going to hide it and leave it like this. All right, this should look at least somewhat familiar to you. Now I'm going to refer to this as our form. You know what? Technically, it ain't no form. Java doesn't believe in the concept of forms. This, for lack of better words, this is a window. We could have set this up in other ways also. You may or may not have noticed that. I had you choose just the window because it was the easiest one, but we could have chose a frame or done a bunch of other stuff. We go into that, again, in chapters 12 and 13. What's the difference between those? But I tried to keep it as simple as possible. All right? So if I click over here, Just go ahead and single click right here on it. You don't have to double click, but single click. What you should notice down here is you get a properties window. All right. This stuff is in a little bit different position as opposed, you're probably used to seeing your Project Explorer up here and your properties window down here when you're in Visual Studio. Can you move them? You might be able to. I've never really investigated it. And I don't really care, to be honest with you. All right. So, a couple things as we take a look at what's in here. It says that right now, by default, we're using, bless you, a border layout, which we're going to change in just a minute. All right. And we're using a container class. The background has got this gray color. It is enabled. We're using a certain font. And this is the color for our foreground. All that makes sense. That should be very simple to you because I believe, correct me if I'm wrong, but I believe everyone in here is in the C# class. Now, I could be wrong. There might be one or two of you that aren't. But if you're not, please tell me if that doesn't make sense to you. All right. Now, what I'm going to show you, you don't technically have to do, but we're going to do it so you see some of the stuff that's in here. I'm going to click the ellipsis, the 3 dots that are by background. So I'm going to literally click that ellipsis. And what it shows you when you click the ellipsis, these are the 13 built-in colors in Java. You've got access to, 16.67 million, but these are the ones that you get by default. Well, they're not web safe. They're not, no. This is a programming language and not necessarily a web programming language. So these are the colors that they gave you. So I'm just going to choose cyan. You could choose any one you want. All right, but I'm just going to click there and click OK. And is it pretty obvious what happened there? All right. Now, I'm going to go to foreground and click it again. And notice the same thing comes up. And this says by default, what? Our text is going to be black. If you want to keep it black, which is fine, then don't change it. If you'd rather give it one of these other colors, don't make it cyan. Don't make it cyan text on a cyan background. All right. But if you want to choose something else, I'm just going to leave it where it is. But just to show you, as it is also in the Visual Studio, background is the background and foreground is the color of text. All right. We're going to do one more thing and then we're going to take a break. I'm going to go to where it says layout here. I'm going to click the down arrow. And I'm thinking this is going to change it. I didn't do it this way the other day, which is interesting. I'm trying to do this without my notes. All right. So choose absolute layout. So click where it says layout there and choose absolute layout. And if you raise your hand, you go, I don't know if it worked or not. Let me show you another way you can do it. So I can click there and choose absolute layout, or I can single click up here under layouts where it says absolute law, but it's layout. I can click there. Then I could, and notice it's pushed in, so I could take it and drag over here and let go. That should do the same thing. If you're afraid it didn't, then do it this way, because I know that way works. Do you see the green border that's around it now? It's showing me that it's an absolute layout. Why is that important? That means basically what's going to happen is as I put stuff out here on my GUI, it's going to stay right where I put it. All right? Unless I try to put 800 things on one line. Of course, that wouldn't work. All right? So it's 10:45. This is a good time. Why don't we save what we have, and let's take a break. Let's come back at 11, and we'll see how much of this we can get done.